Hello and welcome to the NPTEL MOOCs course on Design and Implementation of Human-Computer Interfaces, lecture number 25, where we are going to continue our discussion on implementation and testing. So, let us first quickly have a look at what we have covered so far and where we stand. So, we are discussing the interactive system development life cycle. It consists of several stages. Among those stages, we have already covered some stages and currently continuing discussion on some other stages, and in future also we are going to cover the remaining stages. So, which are the stages that we have covered so far? Let us have a quick look. So, we have covered requirement gathering, analysis and specification stage. Then we have covered design stage, prototyping stage, early evaluation of the prototyping stage. Now, this design, prototype, evaluation cycle is primarily meant for interface design, keeping usability in focus. So, we have covered all the three sub stages of this cycle for interface design. Subsequently, we covered design of the system or code design. Then we discussed in the previous lecture the coding and implementation stage, where we learned about coding practices, what we should do, what we should avoid while writing a program. So, currently we are going to pay our attention to the code testing stage, which is our topic of this lecture. So, what is code testing? First of all, why we need testing? As the name suggests, testing means we need to test the code, but why? So, primarily there are three reasons for testing our code. First is to know if the code is written with proper syntax. Why that is required? So that we can compile the code and create the executable program. So, essentially we need to check for syntactical correctness of the code. Secondly, we need code testing to know if the code performs what it is meant to perform. So, it produces the expected outcome after execution. That means, we need to test whether the code is logically accurate. It does what we want it to do. There is another reason which is equally important, that is, we need to go for code testing to know if the code follows convention, so that others can understand and maintain the code. Now, this is very important. Not only syntactical and semantical correctness, we also need to test code specifically keeping in mind the maintainability of the code. Others can understand the code, others can modify the code, in summary others can maintain the code. This is required to implement a team effort, and for that also we need to go for testing of the code. So, once we know the reasons, the next thing that comes to our mind is how we can test our code keeping in mind these three objectives. First one is syntactical correctness, how we can check for syntax of the code, whether the code syntax is correct or not, whether we have written the code correctly or not. That is simple. Generally, that is the most simple part of code testing. We rely on the compilers, which typically comes inbuilt with the integrated development environments. I think most of you have probably already used such IDEs and the inbuilt compiler to check for syntactical correctness of your code. The other two testing situations, namely testing for logical correctness and testing for compatibility with convention, our IDEs or the inbuilt compilers cannot be of any help. These two are generally more difficult to test and more complex in nature, and there are actually several methods to take care of these two types of testing. So, let us have a quick look at different testing methods. Now, there are two broad categories of methods. One is review based code testing, other one is execution based code testing. So, whenever we are talking of code testing, our primary emphasis is for testing of logical correctness and testing of conventions, whether the code is following the conventions. Now, to do that we can apply any of the several methods available. Broadly, all the testing methods can be divided into two categories. One is review based testing, one is execution based testing. Let us first start our understanding with the review based code testing. Now, review based testings are relatively less rigorous, but they are also quick methods for testing of your code. So, although they are not very rigorous, but they can be used to test code quickly. Generally, such testing are carried out after a module or an unit is successfully compiled and all syntax errors are eliminated. So, once you implement an unit or module and compiled it and found out that there are no syntactical errors, then we can go for review based code testing for that particular module. Now, review based testing offers a cost effective strategy for reduction in coding errors and production of high quality code. Of course, that is the ultimate objective of any testing method, that we identify errors, address them and produce high quality code. Now, review based testing provides a cost effective way of doing the same thing. It produces high quality code to some extent with methods that can be applied quickly and with less cost. So, review based testing also can be done in different ways. Broadly, there are two ways. One is code inspection, which is somewhat similar to heuristic evaluation that we have earlier seen during our discussion on evaluation of prototypes. Remember, there we mentioned that heuristic evaluation is a kind of checklist type evaluation where we tick from a list after checking the prototype. Similarly, code inspection is kind of similar method where we have a set of predetermined things to check and we take the code and go through it and see whether the things that are there in our list, in our checklist, are satisfied in the code or not. So, here in code inspection method, there will be an evaluation team just like heuristic evaluation for prototypes. Team members will check the code for violation of coding standards. So, we have a checklist of standards to be followed while writing a code, and the team members goes through the code and see if there are any violations. The other method is code walkthrough. Again, this is similar to the cognitive walkthrough method that we have seen or discussed earlier in the context of evaluation of prototypes. So, in case of code walkthrough, again there will be an evaluation team. Each team member will manually execute the code. This is often called hand execution. I think many of us probably have done that during our code writing practices, and the team members will do that for some test cases which are to be representative test cases to identify logical errors. So, like cognitive walkthrough, there are some usage scenario which we call test cases, which ideally should be representative test cases, just like in the case of cognitive walkthrough, and those test cases will consist of input and output. The members of the evaluation team will hand execute or manually execute the code for the given input and see what output is getting produced, and we will compare with the desired output and see whether there is any problem with the two outputs, whether they are matching or not, to find out if there exists any logical error in the code. These are broadly two ways to go for testing of code. In other words, we review the code. In case of inspection, primary objective is to check if the code follows the standards, and in case of code walkthrough, primary objective is to check if there are any logical errors with respect to some representative test cases. So, how these methods help? These are quick methods similar to the prototype evaluation methods, namely heuristic evaluation and cognitive walkthrough. These methods can also be applied in a relatively quick way. So, eventually they help us save development time. Of course, they are not rigorous methods. So, after applying these methods, it may happen, in fact it is quite likely to happen, that some errors are still there which we could not detect through these methods, but idea is that we identify as many errors as possible with this quick method, so that the quality of the code improves. Code inspection helps to conform to good coding practices, which in turn helps in maintainability and portability of the code. These are very important achievements when we are looking for team effort. Code walkthrough, on the other hand, allows the developers to quickly identify logical errors. Of course, some errors may still be missed, because it is not possible for a complex system to come up with all possible test cases. But if the test cases are chosen carefully, if they are representative, then major points where logical errors can happen, major areas of the code can be quickly identified. So, that is all about review based code testing. The other type of code testing is execution based testing. Unlike review based, where we primarily go through the code manually and do the testing, in execution based that is not the case. So, review based testing is somewhat informal. They are primarily meant to evaluate the code qualitatively. That is 100% true for inspection based method, but partly true for walkthrough based method, although in walkthrough also one of the objectives is to identify violation of coding standards along with logical errors. So, if we are performing review based testing, they may not be able to give us all possible errors. So, such type of testings are good for early evaluation, similar to prototype evaluation and testing. Now, that early evaluation helps us to clean up the code before more rigorous and formal testing is done. So, eventually we have to go for somewhat rigorous and formal testing, but before that we can apply the code review methods to kind of pre-process the code and clean up some important errors. Now, the formal or rigorous testing consists of providing the program a set of test inputs, which popularly is known as test cases, and then observing the behavior of the program, in other words the output primarily. So, these are the things that we generally do with more rigorous and formal program testing methods. If the program or the code fails to behave as expected, that means the output that it generates is not the same as the output that is expected for a given input, the conditions or the inputs under which failure occurs are noted for later debugging and correction. So, that is the way to go for more rigorous and formal program testing. So, before we learn about the formal testing methods, let us quickly learn about the terminologies that we are going to use in the subsequent part of the lecture and subsequent lectures. First term is test case. This is a very common term that we are going to use throughout this lecture and the next lecture. A test case can be considered to be a triplet: I, S and O. So, here I stands for the input data, S stands for the state of the system at the time of providing input data, and O stands for the expected output. So, that is the meaning of the triplet, and this triplet is popularly called a test case. However, for simplicity in subsequent discussion, we will consider only the doublet I and O. So, we will not generally consider S, that will unnecessarily complicate the discussion without adding much value. So, we will generally consider the doublet I and O to be representing the test case. Closely related to the term test case is the term test suite. Now, a test suite refers to a set of all test cases with which a given software is to be tested. So, generally we test a program or a software with a set of test cases rather than a single test case. Now, this entire set is popularly called a test suite. So, what is the aim of testing? To identify all defects or problems in a software product. But is that feasible? Is that viable? In practice, it is generally not possible to guarantee that a software is completely error free after testing. No matter whatever way we try, no matter whatever method we apply, it is practically impossible to guarantee that after testing we will be able to identify all possible errors and we will be able to rectify all possible errors. That is not a practical way to think of testing. Instead, what we can do is something different, but before that, why it is not possible? Because input data domain, that means the set of values that can act as input, for most of the real life software products are generally very large in size. So, the possible set of inputs is very large in most of the practical systems. Then it is not practical to test a software exhaustively with respect to each and every possible input, because that will consume huge amount of time if at all we manage to do that. Now, a logical question can be, if it is not possible to test everything and it is not possible to identify all possible errors, then what is the purpose of formal testing? Review based testing would have been sufficient. Why to go for testing at all? We have to look at this problem from a different point of view. It is not binary that either we test and find out everything or we do not test. Rather, our objective should be we test to find out major problems, knowing very well that some of the problems may still escape our attention. However, our objective should be to identify all major problems. So, testing does expose many, rather most defects, which are the important ones if done properly and systematically. Now, these two are very important. So, we cannot go for testing with random test cases and randomly created test suites. Rather, we have to adopt a very appropriate method which has to be carried out in a very systematic manner, so that we are able to identify the important problems or important defects with the system. That is our goal rather than identifying all possible defects. In that way, it is more practical to reduce important defects in a system, and that in turn is likely to increase confidence in a developed system. So, if we do not do testing, then the end users or the clients may not have the confidence of using the system in real life situations, and there may always be a thinking that the system may fail because we have never tested it. On the other hand, if we test it and identify important issues, then at least we know where it can fail and we can rectify for those scenarios which are likely to be the most important and most frequent ones. For some minor issues, there can always be some bugs which we can always fix later. We have to always keep in mind that it is not possible to come up with a perfect system. That does not exist. Whatever software we develop, we have to have this knowledge that there will always be some bugs even at the end of a very rigorous testing phase. So, the key thing here is that we need to go for a proper method with systematic application of the method to identify the major defects that are most important ones. Now, exhaustive testing is impractical because possible input data values are likely to be extremely large or infinite. Then we must design test suite that is of reasonable size and can uncover as many errors existing in the system as possible. That is our goal. If we select the test cases randomly, then they not necessarily contribute to the significance of a test suite. That means they need not detect additional defects not already detected by other test cases. So, the total number of test cases in a suite not necessarily indicates the testing effectiveness, where effectiveness is defined in terms of identification of major or important defects in the system. Large number of test cases selected at random does not guarantee that all or even most of the errors will be uncovered. So, our objective should not be to go for a set of randomly decided test cases, even if that leads to a very large test suite, because it is very unlikely that that test suite will lead to uncovering of errors that are not already detected with a smaller suite, or even it will lead to uncovering of important defects with the system. To understand this point, let us take one example. Suppose we have written a code to find the larger of the two integers. So, the code snippet is given here. If x greater than y, then max equal to x, else max equal to y. So, if x is greater than y, then max equal to x, and if x is less than y, then max equal to y. So, this is likely to give us the larger or greater of the two integer values. Now, here instead of y, suppose originally it was written as x. So, the code has a simple programming error. So, although y should be the right one, but instead while writing the code, the programmer has written else max equal to x as shown here. So, the y is not present. So, this has a simple programming error. Now, how do I identify this error? Let us see how we can design test cases to identify this error. Consider a test suite consisting of two test cases, x equal to 3, y equal to 2, that is the input, and output is 3. Similarly, in the second test case, x equal to 2, y equal to 3, and the output is 3. So, in the IO doublet form, we have in each test case we have the input and the output mentioned. Now, with this let us see how we can identify the programming error that is present there. If we put x equal to 3 and y equal to 2, then we can see that the output will be 3. So, for the first case it produces the correct output. For the second case, when we have x equal to 2 and y equal to 3, this condition fails, it goes to next condition and then it produces 2. So, there is a mismatch, instead of 3 it produces 2. So, here we have a mismatch. And then we know that there is some error. Once this error is detected, we will be able to identify where exactly the error is and we can rectify it. Now, let us consider a larger suit consisting of 3 test cases like before: x equal to 3, y equal to 2, output is 3, x equal to 4, y equal to 3, output is 4, x equal to 5, y equal to 1, output is 5. With this, will it be possible to identify the error? Let us see. When x equal to 3, y equal to 2, we get output 3, it matches. When x equal to 4 and y equal to 3, again we get output as 4, it matches. So, we do not detect any error. And finally, when x equal to 5 and y equal to 1, again we get 5 as output. So, again we do not detect any error. So, eventually every time with the given input we get the desired output, which is exactly what we want. So, there is no mismatch. So, we conclude that there is no error, although we can see here that there is some error. So, this test suit cannot detect the error, although this test suit is larger in size. So, larger test suits not necessarily give us a better test suit. So, the moral of the story is, if you do not choose your test cases carefully and create your test suit appropriately, then no matter whether the test suit is larger or not, you may not be able to identify the error. That means, you will fail in your objective of detecting errors. So, the implication is test suit should be carefully designed. It should not be decided randomly. That is the implication of this discussion. Now, this careful design of test suit requires some systematic approaches. How we can do that? So, that systematic approach can be done in either of broadly 2 ways. Functional testing. So, when we are trying to perform a test of a code, we need to systematically design the test cases and apply the testing method. Now, this systematic approach to testing can be done in broadly one of the 2 ways. One way is functional testing. Here, test cases are designed using only functional specification of the software. That means, without any knowledge of the internal structure. In other words, suppose we have written a function add int 1, int 2, and it returns an int. So, there are some statements and this is the function. So, when we are testing, we design the test case based on only the definition of the function. That means, it takes as input 2 integers and produces as output 1 integer, rather than what is written here inside the body of the function. So, this body we simply ignore and we test based on the definition of the function. One popular way of going for this type of testing is black box testing. As the name suggests, we treat each function as a black box, only the declaration part is considered, the internal or structural part is ignored. So, we simply assume add function to be a black box, and what is there inside the box, that means the body of the function, is of no concern to us. In that way, we understand the function, and with that understanding we create the test cases to test the function, that is black box testing, which is a type of functional testing. As opposed to the black box testing, there is another method that is called structural testing. Here we decide the test cases based on the knowledge of the internal structure of the code. Unlike in case of functional testing or black box testing, here we are concerned about the internal structure, that means the body of the functions and the body of the code, and based on that knowledge we design the test cases. One example is white box testing, which is a kind of structural testing. So, in summary, we go for testing to uncover errors present in the code. Testing can be done in broadly two ways. One is a quick and cost effective way, although it is not very rigorous or formal way, that is the review based testing, which also can be done in either of the two ways, namely inspection based testing and code walkthrough. These are similar to the heuristic evaluation and cognitive walkthrough methods that we discussed in the context of prototype evaluation. The other testing method is the execution based testing, which is more formal and rigorous testing method with the objective of identifying more and more errors. Now, in that case we go for actual execution of the system. Now, there are broadly two ways to do that. One is functional testing, one is structural testing. In functional testing, we assume that the functions are black boxes and only the input and output matters. Accordingly, we design the test cases. In case of structural testing, we design test cases based on the internal structure of the code. An example of functional testing is black box testing. An example of structural testing is white box testing. In subsequent lectures, we shall learn in details about all these testing techniques, namely review based testing, black box testing and white box testing. Whatever we are discussing in this part of the course, you can find from this book, Fundamentals of Software Engineering, chapter 10, or Software Engineering Practitioner's Approach, chapters 19 to 21. Of course, there the things are discussed in much more details than what we are discussing here, but those are useful references where you can enhance your knowledge. I hope you understood the concepts and enjoyed the topics. We will continue our discussion on testing in the next lecture. Looking forward to meet you soon in the next lecture. Thank you and goodbye.